Good day, ma'am. Today I'm going to present and prove the Cot Cubed Spider problem, which states that a cube of cotangent A is equal to the following expression. In simplifying expressions with more than one single fraction line, we're going to split it up for a thorough dissection and simplification for convenience. And the first major split up, we're going to split up into the numerator and the denominator, denoted by the yellow strip and the orange strip respectively. First is the numerator part, which we are going to dissect into three parts: the yellow, the orange, and the green. The first, we're going to simplify the yellow expression. The cotangent of A times 2 of the square of the tangent A plus the cotangent of A. Seeing this, we may observe a common factor among the expression, which is the cotangent of A. Therefore, we are going to divide the expression with cotangent of A, which will result into this. The cotangent of A multiplied to the 2 of the square of tangent of A plus 1. We can still expand the expression. We can expand the 2 to the square of tan into tan squared plus tan squared. And remembering the Pythagorean identity of tan squared plus 1 equals the square of sector A, we can substitute this expression, which is the tan of squared A plus 1, which will result into the cotangent of A times the square of the tangent A plus the square of sector A. Moving on to the orange strip, this expression is a fraction. Therefore, we can expand it by dissecting it using the plus sign. We can see a common factor among the numerator and the denominator, particularly in the second fraction. Therefore, we could cancel the cotangent of A, which will result in simply the 2 of the square of cotangent A over cotangent of A plus tangent of A. Seeing this, we can still observe a common factor among the expression, which is the tangent of A. Dividing this expression into tangent of A will result into the tangent of A times the 2 tangent of A over the cotangent of A plus 1. Dividing the 2 square of tan of A over cotangent of A by tan of A will result into 2 tan of A, wherein the degree 2 is subtracted by a degree of 1 from the tangent, and the tangent divided by the tangent is equal to 1. Next, we are going to dissect or simplify further the 2 tangent of A over the cotangent of A. 2 tangent of A divided by 2 cotangent of A. We are to remember that cotangent is the reciprocal of the term tangent. Therefore, when we divide tangent by a cotangent, it means multiplying a tangent with a tangent. Therefore, the answer of the 2 tan of A divided by the cotangent of A is equal to 2 squared of tangent of A. Upon seeing this, we can simplify the expression further into tangent of A times 2 of the square root of tangent of A plus 1. Like what we did in the yellow strip, we can still expand the 2 expression in the tangent, in the square of the tangent of A. We can make it the tangent of A times the square of tangent of A plus the square of tangent of A plus 1. We can too still remember the Pythagorean identity of the square of tangent of A plus 1, which is equal to a sector squared of A. Therefore, we can divide the expression isolating square of tangent of A plus 1 and make it the square of sector of 1. Therefore, the simplified orange strip will result into the tangent of A times the square root of the tangent of A plus the square root of the sector of A. Filling in our simplified expressions, we can still see here in the left-hand side of the screen simplified in bold. Next, we are going to simplify further the green strip. Upon seeing this, we know that it's a fraction, therefore, we could divide this fraction into 2 using the plus sign despite of the common denominator present. This will result into this expression. We may see in the first fraction the commonality of the sector of A, therefore we could cancel it. While in the second fraction, we could see the similarity of the cosecant of A, therefore we could cancel it as well. Then, after cancellation, the result will be sine of A over the cosecant of A plus the cosine of A over the secant of A. We are to remember that the cosecant is the reciprocal of sine. Therefore, using the division rather of fractions wherein the second term is reciprocated, when dividing a term with its reciprocal, the answer would be the square of the first term. Therefore, the sine of A divided by the cosecant of A would simply be the sine of A multiplied by the sine of A, which resulted in the square of the sine A. The same can be said rather to the cosine of A over the secant of A. Because of their reciprocal relationships, we are going to conclude that cosine of A divided by the secant of A is simply the square root of the cosine of A. Therefore, we are left with the following expression: the square root of the sine of A plus the square root of the cosine of A. Again, we are going to remember the trigonometric identity, specifically the one which denotes that the square root of sine of A plus the square root of cosine of A is equal to 1. Therefore, we can simply simplify this whole green strip of expression into just one digit, 1. Next up, we are going now to conclude or to simplify in totality the numerator of our Cot Cubed Spider. Because the denominator of our expression is 1, we can simply proceed with the numerator. Upon seeing the numerator, or the fraction form rather, we can see a common factor, which is the square of the tangent plus the square root of the secant A. Therefore, we could cancel them both, which results in the cotangent of A over the tangent of A. Remember, the cotangent of A is simply the reciprocal of the tangent of A. And we have established from the prior processes that a dividing a term with its reciprocal would ultimately result into the squaring of the first term, which we can show in this example. The 1 over tangent of A, which is equal to the cotangent of A, divided by the tangent of A. Because we are dividing, we are going to multiply the reciprocal of it. Therefore, it will result into 1 over tangent of A is equal to 1 over the square root of tangent of A, which is the square root of the cotangent of A. We are now to conclude that the numerator of our Cot Cubed Spider is the square of the cotangent of A. Now moving on to our denominator. Of course, we are going to split up the denominator into parts, the yellow strip and the orange strip. The yellow strip first. We can see that the square of the secant of A divided by the sum of the square root of sine of A and the square root of cosine of A. Again, we are going to remember the Pythagorean identity of the square of the sine of A plus the square root of cosine of A, which is equal to 1. Therefore, substituting this expression by 1 would result into the square root of the secant of A minus 1. Again, we are going to remember the Pythagorean identity of this expression, which states that the square root of the sector of A minus A is equal to the square root of the tangent of A. Therefore, we can conclude now that the yellow strip is equal to the square root of the tangent of A. Simple as that. Moving on to the denominator of the denominator of the denominator, which is denoted here in the yellow strip. Of course, seeing this, it is also a fraction, but we're first going to simplify the numerator. The tangent of A multiplied by the cotangent of a term multiplied by its reciprocal would always result into 1. Therefore, we can conclude that the numerator, simplified it, is equal to 1 divided by the square root of sine of A, while the denominator remains untouched. Again, the Pythagorean identity of the trigonometric functions, 1 minus the square root of sine of A is equal to the square root of the cosine of A. It's the same rule as the previous one that we have established, but due to algebraic manipulation, it remains to be different. Now, we can substitute the numerator by the square root of the cosine of A, which results, our expression will result into the square of the cosine of A over the cosine of A. Due to this, We can now divide the expression, but for a shortcut, we are going to use the exponential rules. When dividing two terms with the same base, we're going to just subtract their exponents. 2 minus 1 will result into the cosine of A. Therefore, the square root of the cosine of A divided by the cosine of A is equal to the cosine of A. Okay, upon concluding what our values for the denominator of our spider is, we're going to substitute it into this expression, which states that the square of the tangent of A over the quotient of the sine of A and the cosine of A. The square of the tangent of A over the sine of the tangent of A over the cosine of A. We're going to remember the trigonometric identity of the tangent of A, which is equal to the sine of A over the cosine of A. Therefore, we're going to substitute the orange strip into simply a tangent of A. Therefore, the square root of tangent of A is divided by the tangent of A. We can simply now divide it by subtracting a degree 1, which results into the tangent of A. Therefore, the whole expression in our denominator can only be summed up as the tangent of A. To wrap up, to conclude our problem, we are going now to simplify the values of the numerator and the denominator to effectively deduce whether the cube of the cotangent of A is really equal to the expression that we have presented beforehand. Now, the square of the cotangent of A divided by the tangent of A. Using division by fractions, we're going to multiply the first term by the reciprocal of the second term. Because the first term, the square of the cotangent of A, is equal to the reciprocal of tan, which is equal to 1 over tan over A, we're going to use it for brevity. Now we have 1 over the square root of tan of A multiplied by reciprocal of the tan of A, which is 1 over tan over A, which results into 1 over the cube of tan of A. Now remember that 1 over a ton, whether any degree has been placed in it, is always equal to cotangent. Therefore, we can simplify 1 over the cube of tan of A into the cube of cotangent of A. Therefore, we have effectively proven that the cube of the cotangent of A is really equal to the following expression. Now that we have solved the Cot Cubed Spider, I think that we are very prepared to move on into the more harder, more complicated problems. Thank you.